The Mississippi River is dying in real time. In just 72 hours, water levels have collapsed 47%, exposing riverbed that has not seen sunlight in recorded human history. What geologists are finding on that exposed floor should not be there because ancient fissures are splitting open, and material buried for thousands of years is finally surfacing today. On February 25, 2026, at 6:47 in the morning, automated gauge stations along the upper Mississippi begin transmitting data that stops every engineer cold at the monitoring center. The numbers on the screens are not a sensor malfunction or calibration error, as the river is dropping at rates that exceed every worst-case scenario in the official database. By 7:15, the Memphis station confirms what upstream sensors have been screaming for hours. Water levels at Memphis have fallen 19 feet in less than 72 hours of time. This reading represents a massive 47% reduction in flow volume, forcing engineers to stare at figures that belong in a geological catastrophe simulation rather than a live data feed. At 8:02, the Vicksburg gauge follows, then Natchez, then Baton Rouge, as the drop cascades southward along the entire lower Mississippi corridor like a wave of impossible numbers. The United States Army Corps of Engineers activates emergency protocols at 8:30, immediately issuing navigation warnings to halt all barge traffic across the vital and struggling lower Mississippi waterway. Port operators in New Orleans begin frantic assessments of water intake infrastructure, as the river that supplies drinking water to over 18 million Americans continues its mysterious and catastrophic retreat. By noon, the scope of this disaster becomes impossible to minimize, especially since the National Weather Service recorded no significant precipitation deficit that could explain a drop of this magnitude. There are no upstream dam releases or operational explanations sitting in any agency log, proving the Mississippi River is not responding to anything on the surface, but something happening deep below. Senior hydrologist Dr. Patricia Walters reviews the integrated data with growing alarm, realizing the rate of decline does not match any surface hydrology event ever recorded in the scientific record. When a river retreats this fast, it leaves behind a confession. By the afternoon of February 25th, stretches of the riverbed between Memphis and Vicksburg are fully exposed. United States Geological Survey field teams scramble to reach access points along the bank, finding things that send urgent communications racing up the chain to the White House Situation Room. The riverbed is not behaving like a typical riverbed anymore. As field geologist Dr. Aaron Briggs documents massive fissures in the newly exposed alluvial sediment across a 14-mile stretch, these fractures measure 3 to 7 feet wide and descend beyond the reach of any probe carried by the team, showing sharp edges that suggest they are active and recent. These are not erosion features or channels carved by current over time. They are fractures oriented in a pattern that makes every geologist on the site go very quiet. The orientation aligns perfectly with the new Madrid seismic zone, but the fissures are only the beginning of a mystery that is triggering immediate and strict contamination protocols. Field teams collecting sediment samples from the exposed riverbed begin detecting a strange, black organic material seeping upward through the fresh cracks, causing sensors to trigger alarms instantly. This is not petroleum or agricultural runoff. Carbon dating results from the University of Memphis reveal the material is between 22,000 and 60,000 years old. Ancient organic deposits sealed beneath the Mississippi alluvial plain since before the last ice age are now surfacing through fractures that opened in the last 72 hours. Dr. Renata Okafor, a sedimentary geologist at Louisiana State University, arrives by helicopter to examine the samples with an expression her colleagues have never seen on her face before. She explains that the exposure of these deposits is not a surface phenomenon, as the fractures penetrate deep into the substrate, indicating a subsurface structural failure on a massive scale. Something beneath the riverbed is giving way, and methane readings spike in 3 separate locations along the corridor, detecting concentrations 40 times above background levels rising from the openings. The ancient organic material is not just surfacing, it is outgassing, meaning the riverbed is exhaling gases that have been trapped underground since the last ice age. Scientists racing to document every inch of the floor describe a landscape that belongs to a different geological era, showing the world something it buried tens of thousands of years ago. The reason the river is showing this to anyone at all is the terrifying question that is keeping every geologist on that bank awake through the entire night. There is a sense of dread as they realize the river is not just low, it is acting as a window into a geological power that humans have never witnessed before. Every sample collected and every measurement taken points toward a shifting foundation that could rewrite the history of the North American continent in a matter of days. As the sun sets on February 25th, the exposed floor of the Mississippi looks less like a river and more like a wound that refuses to close. Here is what geologists are not saying in press briefings, because they are saying it in their data, revealing a convergence of multiple catastrophic stressors arriving simultaneously. The 47% drop in Mississippi River flow volume cannot be explained by one cause, as it is a compound failure event that no individual model ever predicted. The first stressor has been building for decades, since the basin has been in a deepening drought cycle starting back in the year 2022. Snowpack across the northern Rockies entered the 2025 winter season at 61% of historical average, while groundwater recharge has been negative for 38 consecutive months. The second stressor is geological, and it has the scientific community most alarmed, because the New Madrid seismic zone runs directly beneath the lower Mississippi River Valley. In 1811 and 1812, this zone produced earthquakes estimated between magnitude 7.5 and 8.0, which were the most powerful events in recorded history. Those massive quakes temporarily reversed the flow of the Mississippi River and created new lakes, where ancient forests had stood for many centuries before the settlers arrived. In the 40 days preceding February 25, 2026, seismometers recorded 417 microseismic events, forming a pattern that experts describe as accelerating fault preparation. The third stressor arrives from below the surface, as the Mississippi embayment aquifer system has been experiencing anomalous and rapid pressure changes since November of 2025. Monitoring wells across Tennessee and Mississippi have recorded rapid depressurization in deep layers, suggesting that the massive aquifer structure itself is changing in a very dangerous way. These pressure losses are not consistent with human extraction, but instead indicate that the subsurface is reorganizing itself under pressures that have been building for many generations. When these three stressors converge, you get a river that is not just draining downstream, but a river losing its entire volume into the earth beneath it. Water is disappearing through new fractures and compromised aquifer layers because the subsurface is releasing tension that has been stored for thousands of years all at once. The hydrological models were never designed for this scenario, and the future of the American continent has arrived without asking for permission from any government agency. Engineers are now realizing that the riverbed has become a massive drain, pulling the lifeblood of the nation into a dark abyss that no one can possibly plug. The crisis is no longer about a temporary drought, but about the permanent geological failure of the most vital waterway in the entire Western Hemisphere today. Scientists at the University of Memphis warn that the silence of the primary fault zone is the specific kind of silence that usually ends without any warning. As the data continues to pour in, the terrifying reality is that the ground is literally opening up to swallow the mighty Mississippi in its entirety. 18 million Americans drink water drawn directly from the Mississippi River system, which is a number that is no longer an abstraction, but a crisis with a face. Water intake facilities serving Memphis and the greater New Orleans area begin registering critically low levels by the morning of February 25th as the river continues its retreat. Engineers at the East Jefferson Water System in Louisiana activate emergency conservation protocols before noon, issuing mandatory water restriction orders to residents across 6 different parishes. These notices tell people to stop all non-essential water use immediately because the operational capacity of primary intake pumps is now threatened by the falling river surface. In Memphis, the Light Gas and Water Division warns that pumps designed to function at much higher levels are now only 6 feet above the current river surface. If the river drops another 4 feet, Memphis faces a drinking water emergency for a city of 630,000 people who have no alternative source. The barge industry collapse is immediate and total, because the lower Mississippi carries approximately 500 million tons of vital cargo annually for the entire nation. Grain, coal, and petroleum products, moving between the American interior and the Port of New Orleans, all come to a halt on February 25 as navigation depth is breached. Grain elevator operators watch in real time as the price of alternative transportation to coastal export terminals calculates itself into a state of total economic ruin for farmers. A bushel of corn that costs 11 cents to ship by barge now costs 63 cents to ship by rail, creating losses that no insurance product covers. The Port of New Orleans goes quiet in ways not seen since Hurricane Katrina, as terminal operators halt loading and container vessels waiting offshore receive indefinite delay notifications. This economic ripple moves outward from the river in every direction simultaneously, and it does not stop at the water's edge, affecting global supply chains within hours. 3 nuclear facilities operating near the lower Mississippi corridor, including Riverbend and Grand Gulf, notify the Nuclear Regulatory Commission of highly anomalous intake conditions. These plants draw cooling water directly from the river, but current levels no longer support the infrastructure designed to keep the reactors at a safe and stable temperature. Both facilities activate contingency cooling protocols, while emergency engineers work through the night to calculate the catastrophic threshold where these pumps will finally fail to function. For 3 major cities along the lower corridor, that margin of safety is now less than 5 feet, and for one city, it is less than 3 feet. The terrifying arithmetic of a falling river means that a city can go from having a water supply to a total dry tap in a matter of hours. Local hospitals and fire departments begin preparing for a reality where the hydrants are empty and the cooling systems for critical medical equipment no longer have water. At the USGS National Center in Reston, Virginia, geophysicists analyzing the integrated data stream are having internal conversations that they are not yet having with the general public. The pattern emerging from the combined seismic, hydrological, and ground deformation data is not consistent with simple drought or groundwater depletion alone in any modern scientific framework. Data describes subsurface structural deformation beneath an active river corridor, indicating that the riverbed is not just losing water, but the entire substrate is moving. GPS ground deformation sensors installed as part of the EarthScope network recorded significant vertical land motion anomalies in the 72 hours preceding the massive water drop. Monitoring stations near Greenville, Mississippi, showed subsidence of 1.3 centimeters, while stations near Helena, Arkansas, recorded subsidence of 0.9 centimeters. While these are not large numbers individually, they represent something extraordinary in the context of a river corridor that should show near zero vertical motion. Dr. Sylvia Marchand, at the St. Louis University Earthquake Center, pulls up seismic tomography data and compares the subsidence pattern to the known fault geometry beneath the valley. The correlation is close enough to make her call her department chair at 11:45 at night because the subsidence is occurring in zones that overlay mapped fault structures. Secondary New Madrid structures are experiencing accelerated creep, a slow, aseismic movement of fault surfaces that generates no large earthquakes but produces subtle and deadly ground deformation. What creeping faults beneath a river valley mean for surface hydrology is not a solved scientific problem, but the hypothesis forming among experts is not a comforting one. If these structures are experiencing accelerated movement, the alluvial sediments and fractured bedrock may be developing permeability pathways that allow water to drain into the deep subsurface. River water is draining into the ground at rates that no surface hydrological model has ever been required to account for in the history of modern engineering. The river is not disappearing into thin air but is vanishing into the ground, which happens to be the most seismically dangerous real estate in the eastern United States. The Mississippi River is the load-bearing wall of American civilization, but the assumptions embedded in every bridge foundation calculation are now becoming terrifying questions rather than certainties. 14 major bridges carry highway and rail traffic across the lower Mississippi, and every one of them was engineered to assume stable flow volumes within historical ranges. When the riverbed drops and the substrate begins to shift, the structural integrity of these critical arteries becomes a gamble that the nation cannot afford to lose right now. Sonar imaging of the river pier foundations for the Hernando de Soto Bridge revealed data that was immediately classified as sensitive infrastructure information and hidden from the public. Scientists monitoring the Mississippi crisis are watching 4 specific indicators, because any one of them changing in the wrong direction transforms an unprecedented disaster into a category they cannot handle. The first indicator is the rate of water level decline, and if this rate accelerates again overnight, it means the subsurface drainage pathways are widening rather than stabilizing for now. Wider pathways mean faster loss, and faster loss means the timeline for critical infrastructure failure compresses from many days to only a few hours of time for the entire nation. The micro-seismic swarm building for 40 days must not escalate, since the National Earthquake Information Center monitors any event above magnitude 2.5 within the primary fault zone. On the night of May 2, 2026, those alerts have not triggered yet, but scientists are watching the silence with the specific kind of attention that knows silence ends. If methane concentrations keep climbing from the exposed fissures, it means the subsurface structural failure is progressing rather than stabilizing, signaling a deeper collapse that humans cannot stop. The fourth indicator is ground deformation, and if GPS stations record additional subsidence events overnight, then the terrifying fault creep hypothesis is confirmed as the primary cause of this disaster. Emergency managers in 6 states are spending tonight making calls that their emergency plans were never written to anticipate, because the Mississippi River is the load-bearing wall of civilization. 31 states drain into its basin, and the agricultural economy of the entire American interior moves on its current, and right now, that vital system is failing in ways science cannot explain. The atmospheric conditions feeding the drought cycle are no longer anomalies, but the signal of a climate system reorganizing itself faster than any model predicted for the year 2040. The Mississippi did not break in 72 hours, but instead, it was breaking for many decades, and February 25th was simply the moment the fractures became impossible to ignore. The river is still falling, the fissures are still open, and ancient material buried beneath its floor is still rising to the surface as the nation watches in total silence. The question every geologist, hydrologist, and emergency planner is asking tonight has no comfortable answer. Is this the final warning shot, or has the main event already begun for America?